Okay, so now for the third family اللي هي pollution. Si.3-POLLUTIon night light pollution reduction. Night light pollution reduction انتوا بتعرفوا during the nights في some buildings that have a lot of trespassing lighting or upward lighting اللي هو بتشوفوه من فوق وبتشوفوه حتى إذا قاطعين حد البيلدينج. بيكون في كتير light that is directed upwards على السماء وفي light that is trespassing يعني عم بيطلع برات البيلدينج. بكونوا قاطعين بالسيارة بتشوفوا ضوء جاي من المبنى. So the purpose of this criterion is to reduce this, to minimize the light pollution, the night light pollution. أول شيء بنسأله, we ask if the project has external lighting. If it does not have any external lighting, automatically, ما بيقعد qualified for this criterion. First of all, we ask if it has external lighting. Second, نسأله شو هو lighting zone classification. There are standards that classify each area by lighting zone. We have no ambient. No ambient قصدنا يعني مثل forests أو areas that are غابات وما في شيء أبدا سكن. up to LZ4 يلي هي high ambient lighting يعني عم نحكي مثل الداونتاون. Okay, it goes from 0 to 4. So the higher the lighting zone, the higher the threshold, the acceptable threshold. Let's say نحن zone LZ3, automatically the minimum requirements the maximum requirements are بيعملون update بالtable below. And let's say إذا رحنا على Z4 the thresholds are higher, نرجع على 0 thresholds are very low. Okay? So let's say we are in lighting zone 3. The first requirement is to have all indoor lighting will be automatically switched off outside working hour. Yani if we have an office building, for example, and after working hours, let's say working hours from 8 till 6, after 6 o'clock, everything inside should be turned off automatically. So if this is met, we can put here yes, pass, weight factor 1. Second requirement is related to external lighting. Here the maximum percentage uplight, what we mean by uplight is the percentage of lumens that is directed above 90 degrees from the building, يعني upwards. We can go up to 3% of uplight. Here let's say we have 2, it will pass. We should always be less than the maximum. And also vertical illuminance, this means at the side boundary, we must have a maximum lux level at the side boundary. This is called trespass. So we're trespassing on neighboring areas or neighboring roads. The maximum here is 2. If we are 1.5, we can reach a score of 100%. If one of them is beyond the limit, let's say here 3, it will be 67%, 2/3 of the score. Okay? Any question? Okay. Second one, 3.2, stormwater management. It is related to how much the site replicates the natural hydrology of the area, because every natural site can store its own water and can infiltrate its own water within the land. The first thing we do is we enter the site area, which is automatically from other windows. Next, we input the area that is where water is, stormwater or rainwater is being collected. Say it's 600. Also, areas where we have ground infiltration. Ground infiltration means like landscaped areas that has open bottom, not concrete, and then we have put gravel or sand on the top. Next, the next part is area discharged into public sewer. This is automatically calculated. It is the site area minus the areas that is where water is being collected and areas where water is being infiltrated. This is the percentage of the runoff water reduction. So let's say we have here 1,000 site area. We are doing collection of 900, so it's 90%. And in addition, there is a requirement for stormwater treatment of stormwater on site. So if we have a runoff of water from the site, we have to treat it before dumping into public sewers. This can be done either through oil filters, oil traps, can be done either also through infiltration, through sustainable drainage systems. So in order, the score is calculated based on these two values. Each one has a weight factor of 1. So if we have here, I will modify the formulas, 100 by 100, we reach a score of 100. If it is less, it is calculated based on the average between the two. Okay? Questions? Yeah.
You're saying there's a requirement to treat the stormwater?
Yeah.
Why?
Before exiting the site. So, for example, stormwater, rainwater.
Oh, it's the first time I hear about it.
For example, if you have a site with a big parking area, outdoor parking area, okay, you have cars parking outside, there might be some oil leakage from the cars. So it's always better, the stormwater collected from the parking to go through an oil interceptor, okay, before exiting the site to public sewers, okay?
This is clear in the guidelines?
Yes, yes. Yes.
So we don't have to like create a treatment plant for the...
No, it's basic treatment, okay. The minimum recommended by standards. Okay. Okay, so this is related to sewer water. Next is wastewater treatment. First, we ask if there is a wastewater treatment provided for all buildings on site. You have two options, either on-site or off-site, because some sites are on a campus. You might have one treatment plant for the whole site, and some you have one building and one treatment plant for this building. So either this or this, yes, here it doesn't matter, because we have an on-site treatment plant. Also, we are asking if the site has commercial kitchens, because if we have commercial kitchens, we have to install grease traps, okay? So if it has commercial kitchens, yes. Grease trap provided, let's say it's no, the score will be 75%, because the weight factor is 3 for the wastewater treatment for the whole site and 1 for the grease traps. If we put here yes, we will reach a score of 100%. Okay? Next one, it's air pollution reduction. This is related mainly to emissions from on-site generators and from boilers, from fuel, diesel, or gas boilers. First question we ask is there any on-site generator, on-site generators? If it's no, the weight factor will be 0, so it will not affect the score. If it is yes, these should be fitted with flue gas treatment. This can be a cyclone, this can be a soot filter, so we have multiple options described within the guideline. If it is no, it will fail. Okay, so here it's yes. Next, we have to check if the site has gas boilers or oil boilers. Project includes gas boilers for heating, yes. Here we have two options. Either all gas boilers are fitted with low NOx burners. If this is okay, so we can meet the full requirement of this criterion. If it is not, if you have like multiple burners or multiple boilers on site, some do meet the minimum NOx requirements and others do not, we have to go into this table and do the weighted average of these burners. Let's say we have not all burners meet this requirement. We have to come here to the second table. Let's say it's heating 1. Rated heating output 100 kilowatt. The acceptable limits are also described within the guideline. We have per European standard for gas class 2 it's 120 and class 3 is 80. This is the NOx emissions milligram per kilowatt hour. Okay, and for light oil it's 185 for class 2 and 120 for class 3. The score will be percentage, linear percentage between the two values. So when you are on class 2, exactly at class 2, the score will be 0. When you go to class 3 and you reach class 3, the score will be 100%. Okay, let's say here it's 50. It will pass, weight factor 1, score 100%. If we have some that are not meeting this requirement, so also 100 and here 200. Okay, see here it will fail, but if we, because it's 125, which is higher than the maximum allowed by class 2. If we go for 150, here it's 100, so it's between these class 2 and class 3 values. The score will be calculated accordingly, and the score here is 75%. Okay? And same applies to the oil boilers, boilers and burners. We select if we have on site or no, the NOx and the output average NOx emissions. Any questions here? Okay. Next is refrigerant management. For refrigerants, you may already know that we have two criteria for refrigerant selection. We have the ODP, ozone depletion potential, that affects the ozone layer. And we have the GWP, which is the global warming potential, which affects which is the greenhouse gases, and it contributes to the elevation of the temperature on Earth. Okay. First question is if we ask if the project includes HVAC systems with refrigerants and or gas fire suppression. We are asking about gas fire suppression because some systems, some fire suppression systems, have GWP or ODP within the chemical composition. So if it does include that, we put yes. And we ask now if they have, if any of the refrigerant or fire suppression gases have a 0 ODP or not. If yes, we're fine. If no, automatically the score will be 0 because we do not accept any refrigerant that has an ODP even of 1. Okay, this is strictly prohibited. Let's put here yes. So all gases and refrigerants have 0 ODP. Now we go into the GWP part. We enter the systems. Let's say it's a chiller plant. Rated cooling capacity 500 kilowatt. Refrigerant charge 50 kilograms. Type of refrigerant. We have a multiple big choice of refrigerants, and all these refrigerants are included in a reference table here and within the guideline. So for example, CFC 11, which is the reference for ODP measurement, the ODP is 1, and GWP as well is mentioned here. So when you select the refrigerant, let's say it's 134A, automatically the GWP is shown. And we have to select the equipment life. For chillers, for example, it's around 25 years. And we calculate what is called the direct effect life cycle CO2 equivalent, which is equivalent to what is the GWP or CO2 emissions from this refrigerant over the whole life cycle of the equipment. Because every equipment has a leakage rate, annual leakage rate that we have to each year check it and maybe refill the system. And we have end-of-life refrigerant loss also when at the end of the chiller's life, we have to remove it, and sometimes they empty the gas into the environment. So this is calculating the overall effect of the refrigerant within this equipment. In order to reach a score of 100%, all refrigerant, as we mentioned before, all refrigerant and fire suppression gas should have 0 ODP and 0 GWP as well. Near 0 GWP in order to earn a score of 100%. Okay? Any question here?
Sorry, you mentioned that you are taking into account the running
yes.
effect and the end of life. What
yes.
about the manufacturing of it?
No, it's
end life cycle or no?
It's only from the date of installation on site up to the.
Why you didn't extend it?
There are no rating system that takes into consideration up till now the whole life cycle assessment.
But you are not copying others, you are making a new one.
It is very costly data-wise because we don't have the data.
Okay.
We have to pay for the data, and this is a free platform. We cannot do it. This is one. Two, I am member of an ISO committee, technical committee that are preparing a standard because there is no standard between these databases to be adopted. So we cannot move from a database to another one without lot of work. So now we are preparing a standard to unify the reference. So this is why mainly it is not done. It is not done in ARZ and it is not done in
Until you get
in other
the
records.
reliable database, okay?
Thank you.
Yes.
So you said it has to have a GWP value of 0 to achieve 100%. That means if there is an air conditioning system, most probably that it will never
Exactly,
achieve
yes. If there is no air conditioning system, it will.
It will get 100. No,
Yeah.
I said if it has an air conditioning system, it will not be a 100.
Look, there are new technologies.
Like nitrogen.
You can see here the ammonia, for example, has a GWP of 0. Here the carbon dioxide also has a GWP of very low, which is the reference for GWP measurements. There are also new other refrigerants that have very low GWP as well. Okay, so you can reach it, or at least you can reach the higher range of GWP.
Like it will never be 100% unless it's a completely green gas.
It's natural ventilation.
Don't
Not
forget
natu-
sorry.
Yeah.
Don't forget if you reach 90% as a building score, you are cutting. So you cannot always have 100% on the criteria.
Yeah, 100%. I'm just
Yes.
thinking out loud to have
Okay.
a discussion. No,
Thank you.
You had another question, right? Yeah. It's answered.
yeah, that's it.
Okay. Next one is site noise reduction. This is related to the impact that our site is doing on the environment, on the neighboring buildings. And mainly, we have to check if there is any noise-sensitive area within 800-meter radius from the building. What we mean by noise-sensitive areas like schools, wildlife, maybe a small forest, mahmiye. So if we have this, we have to check this criterion and check if we can earn a score on this. So let's say we have a noise-sensitive area. It's a nearby school. First, what we need to do is measure the background noise during daytime before the site is operational. Let's say it's 20 dBs during daytime and 18 dBs. This is before the site is operational, before all the equipment, chillers, generators are operational on site. And afterwards, we have to check to remeasure the daytime and nighttime dBAs after the building is operational. Let's say it's 15 and 10. So, sorry, it will be higher. It will be higher, yeah. It will be 25 and 25. So, the threshold here, during daytime, we cannot exceed 5 dBs in additional noise generated from our site to the noise-sensitive area. And during nighttime, we cannot exceed 3 dBs. Okay? So, here we can see the the 25 minus 20, it's 5. So 5 dBs is acceptable. For nighttime, it's 25 minus 18, it's 7. So it's higher than 3. Yes. Yes. This is the impact of our site on the neighboring areas. Okay. We have a different criteria for indoor noise. Okay. So in order to meet the nighttime noise criteria, we have to lower this to 20. So it's 2. It's lower than 3. It's pass. So and in order to earn a score of 100%, these should be 0. So we should have here 20 and here 18. So we can earn a score of 100%. Each 1 dB will affect the score. We want additional dB. Okay.